So as far as these gentlemen, the experts, if you will, any questions about what we saw at the plant on Friday or anything with the discussions today? Rod, take it. You want the mic?
Now I'm loud.
Yep.
So one of the things you mentioned was shrinkage with regards to form liners, and I know that, Dan, you guys had a problem at one point in time with regards to how hot this mix can get sometimes, especially in Florida, which I get. Have you tried pouring on something like concrete as opposed to rubber or plastic? And would it be a problem? I mean, like, would it have to be epoxy coated? Would it have to be, what's the form release? I think you talked about that y'all used, was it Knoxcrete, or what was it that you used?
It was Knoxcrete. We've tried using concrete molds on conventional SCC mud before. I know Nick does it a lot. We've struggled with that. But when that 1-inch wave pattern form liner shrunk, that was the kind of first thought that came to me is, well, I've got the panel that was upside down that's supposed to go to the job site, I've got a panel here that's perfect. That pattern doesn't really have a start and stop point, right? It's just a continuous wave. Why don't we maybe treat that panel, release, wax, whatever might work best, and then use it for that form liner? And so to answer your question, I think that's one other thing that UHPC might do is create, we're getting ready to start a rather complex sound wall panel. One side's fractured fin, the other side's this very decorative form liner. So the idea of pouring the way the ones that were going out of the plant on Friday doesn't really sound feasible. But one thought I had, because Helzer had made a roller fracture fin that if you had to pour double-sided texture, that you could roll it over the top of the form at a certain point of set and get a fractured fin look on that side and your form liner on the other side. So I got thinking, well, why don't we make a roller out of a UHPC, right? Cast, put some studs on the roller, wrap a form liner around it, cast it out of UHPC, wax it or whatever, rather than pour that job in a vertical form. Why? Risk, I guess.
Just to add, a concrete form can work, or a form liner. You just want to avoid things that have sharp corners, because if a poly form liner would shrink from the heat, your UHPC will restrict and can cause it to crack if you don't release at the right time. So if you have anything with sharp corners, re-entrant corners, things like that, you just want to pay a little bit of attention that you don't create stress concentrations.
Do you think the foam caused your temperature to go up because it insulated?
Yeah,
as you're back?
we would release it once we got to a certain point.
Okay.
So, like, not totally remove the foam, but we would start to take apart the forms of some of that. Yeah.
So it can bend.
But it definitely did help.
Okay. Yeah.
It's an insulator.
Yeah.
We have repeated it behind it.
What else do we have for questions?
So one of the things that I see in our market with UHPC is it tends to be over specified. And where you all presented it as a solution to a problem, it's just a cool new thing, and architects think, well, should I specify concrete or ultra high performance concrete? Sure, that has a cool name, and it doesn't have a use, and 9 times out of 10, 8 times out of 10, it ends up being switched to something else, where they're trying to make it used for a particular building type, but it's not really you're not getting the benefit of the product. And that sort of batting average over time, I think, would be detrimental to UHPC. As someone that's promoting the product, do you see that? And does that hit rate bother you, or are you just happy to get in there? And
Anthony, can you restate the question?
The long
Synopsize it, restate it.
Yeah. So the question was basically, he's seeing a lot of projects specified UHPC, and then when it comes time to really get into design and cost, it ends up going back to conventional because it didn't make sense, it didn't add value, and does that low batting average in terms of conversion hurt the industry? My answer, before I turn it to Northwest, who really pervades the market quite closely, at least in this sector, it does not hurt UHPC right now because it at least is spreading awareness. Of course, in time, we want architects to learn so that by the time it gets out, it's rarely being VE'd. But right now, people are still learning and think it's the coolest thing since sliced bread. They'll only do that a couple of times before their owner's rep, or their owner's rep or owner start to say, what are you doing? You're just billing me hours to put these specs out and whatnot. We see a lot of copy and paste. People see UHPC in a spec, they copy it, paste it, don't actually design it in. I don't see that as the way forward. Generally speaking, it either is a project at an inception, they engage the industry, or they put it out with very little thought. It's a conceptual design. Then the GFRC or regular precaster that's called says, hey, wait, you can't do this. That's how they end up UHPC right now, most of the time, unless the precaster goes and pushes a solution. What do you guys see?
I'll just say I kind of brought this point up, I think, a few different times over the course of the last couple of days in terms of how we see the stuff potentially getting used. Everything in our world is kind of driven. You have your architect come in and design this thing, and then engineers deciding how it's going to work, and then you end up with a spec, right? I think that the people who are making these decisions about what's getting used on the building and the material that they want to see on it is going to be changing really drastically over the next few years, because as we've seen in a lot of these slides, all of these universities are really heavily involved in developing UHPC. So you're going to see all these students coming out and entering the workforce, and they're going to be the driving people who are coming in and saying they want to see these UHPC features on these buildings because they've known through all their study now that it'll work. So right now, currently, while we're all asking ourselves questions about it, it's difficult to say this is why I want to use it. Whereas I think 5-6 years from now, we've had enough of these people kind of enter the workforce as engineers and architects, and they're going to say, yeah, I want this on my building. And I think that that's kind of what will solidify it.
Yeah, and our area, the Northwest area, is behind the curve. We're not seeing what you're seeing. We're seeing a very rare one project maybe every 6 months that may have.
The same for a UHPC performance specification for architectural that was generic. It would really allow us to sort of promote that information in a meaningful way that for our design professionals.
I agree 100%. It's a valuable item to have. Certainly call me and we can work on something like that. I've done it with other architects and whatnot. It's just a matter of outreach, having enough time, space, and influence to be able to get it out to the general public. Larry?
So Roy, you touched on it earlier, the importance of fiber orientation and stuff. Can you guys maybe describe the importance of your pouring, how, for instance, even on a flat panel, the recommendation is always to stay behind that wet edge and have start at one side and go all the way across. Can you guys explain so that instead of plopping material in multiple
You might be the best to start that from explaining what happens from the inside out.
Sure. So the question is about fiber orientation, the influence of casting, and what's special about UHPC. You're right, the common recommendation is to pour material and stay behind the fluid edge. The reason is with the surface tension of this material and the high fiber content, if you pour from two directions, you will end up filling your form, but you can end up with a cold joint or a plane that the fibers do not cross. the large part of the beauty of this material comes from what the fibers can contribute to your matrix. So you want to make sure you have fiber continuity. When you really dive into this area, you're going to hear the term preferential alignment all the time. Another part of what I'm trying to work on is getting engineers and architects who understand and then explain what they want for preferential alignment, and not just say, hey, give me preferential alignment, because what does that mean to you? But fiber orientation is a very important part of pouring UHPC. It requires just intentional learning, trial and error. How do I pour this? What do I get from it? You also need to have proper distribution up front. That's where high shear mixers come into play and et cetera. But it is a very important part of proper, the UHPC product you manufacture. When it gets to the field, you want it to have the capacity you thought, and fiber orientation is a big key to that.
How many fibers we've used over the last 16 months, right?
Yeah, and so, I mean, to speak to what Anthony just said, we've tried a bunch of different fibers to make sure that that distribution is there, because it's really difficult. One of the first things I read when I was getting into it is how great PVA is, for this material. And when I was using the PVA, I was seeing fiber segregation. It was balling up on me and stuff. So you kind of go down this rabbit hole, and you take this journey to find something that's got a high enough tensile strength and a good enough bond that it's going to work for you, but that it spreads out inside of your mix, which can be kind of difficult. And then, we talked about flat slabs a little bit and being able to start on one end and keep going. A lot of this stuff, you get perforated panels and things like that. So you've got to be really careful with the way you're filling things in, because you get more and more and more opportunities for those two edges to come together in a not great way. The thing I guess that I tell the guys on the floor in regards to that is I'm like, you always want it to be moving. You kind of don't want it to be static. As long as you're still moving it around corners and adding to it from the back and kind of pushing it around, you're maintaining that fiber network that you're looking for. And that's just kind of a practical hint. Tell the guys you always want it to kind of just be going and moving the whole time.
Chris?
You mentioned perforated. I've been wondering this all week. When y'all make those, I think y'all call perforated panels, they look like lattice to me, where lattice comes. Now, what form what material?
Those were just basic wood forms with styrofoam blockouts, and he just stuck it down with silicone. It was pretty simple. On something like that, even though the UHPC is super heavy, you're not getting enough weight under that styrofoam to try to pop it loose or anything. It's just a matter of placing it correctly. Like I was just saying, you don't want to go add a little bit over here and a little bit over here. You want to kind of still start in the same place and kind of fill it in as you go.
And you treat that styrofoam like you would any block out, in that a very crisp, not only is it the silicone being used to adhere whatever that perforated image is, but you're also beading very small bead of caulk around that perimeter to make sure that when you tear that styrofoam out, you've got a nice finished edge, right, with a very small concave edge to it.
I'll add real quick to that, just so everyone knows. Like in a scenario like that, all that foam's coming out when you strip the component. So you're spending a lot of time afterwards going and poking everything out.
One more consideration to consider when you do perforated panels. It can change how the material dries out as it's cured. It will change the phases of what the color looks like as the drying process progresses. So it's just something, high level to be aware of. So you don't just, approach a perforated panel thinking, I only care about forming and getting it out of the form. It can affect how it dries if you don't remove the form blockouts at the right time. You leave a panel in the form over the weekend versus, you pull one out and pop the forms out in 8 hours.
When you're talking about that perforation, though, when it travels around, like through you guys' screen wall as well, when it comes around those surfaces, do you have to do anything to kind of scratch to make sure that fiber interlinks? So you'll come in there and physically do that as it's going around making that connection?
Yeah, I can't really speak to the engineering side of things, but as I talked about it being in motion, it just stands to reason that if I come around a circle and I meet at a point and just stop, that's bad. So I tell the guys, you come around there where you meet, keep pushing it past that point that it met to give it more of a chance to integrate. And it's not just a point and then stopping. So it's like you reach the point and then you move it. You keep adding behind it the whole time.
So to add to that, what we've seen is the conventional wisdom. You would think like, oh, well, if I just wet the mix up a little more, it'll flow better and it'll consolidate around there. If you get a mix too wet and get that edge too far away, you can have where the paste fills in some of those and it does not bring the fiber with it. The fiber continues in the path of least resistance and the paste will round the corners, if you will. So keeping ahead and staying not too far behind it so that you're pushing it and you're keeping fresh fiber coming from your hopper, you can accomplish a good fiber distribution. You don't normally have to use a rebar or anything to break the edges unless you're you have a delay in batching, you have really, really low relative humidity, etc. But it's achievable, it's been done, and it's not generally a huge issue.
And it's not always pretty. You know, those two forms that were up on display during yesterday, there's a lot of hand pushing and shoving and making sure the material's moving because there were just too many interruptions, and we don't always have a UHP mix that's flowing exactly at the ideal level we'd like it to be. So you get prepared that if you've got a odd, complex thing that you're working on, that guys have gloves on and they're going to get their hands dirty and they're going to make sure that that face surface is constantly moving forward.
Two questions. One, to piggyback on what you just said, if you're pouring something thicker than surface level, that you're requiring 2 buckets, anything you need to do there with, which in that case would be almost backup material?
You talked about like several different batches.
Yeah. So that's what I kind of alluded to before in batch math. If you know that you need 2 buckets or more, it doesn't mean that you can't pour it, but you need to understand the time in between batches and how long you think it'll take you to pour. So if you only need 2 batches and it takes you 15 minutes to turn a batch over, as long as you can start batching once you discharge, you can begin your pouring cycle so that you can have material ready. What we've also seen, like you saw the big brand new orange mud hog there. If you have something with an auger or something, you can discharge into that and just lightly agitate until the rest of the material is ready, or use hoppers. But it is important to consider that up front so that you know and are prepared for what it takes.
My other question was, you mentioned in your slide about extruding UHPC. Again, just thinking about it's difficult to trowel. How is that done, and what's the difference in that sort of product than what we saw being poured? Is it drier product?
You can pour it drier. I will say I personally am not an expert in extruding with UHPC, so I will punt and get back to you. If that's something that you would do or are particularly interested in, I can definitely get the information, and likely Vic has it in the top of his head. I don't think you do much extrusion.
We don't do any, but the gentleman sitting right over here to your left kind of talked to us about it a little bit yesterday, right? Where you said there's a hopper and pumps. The guy from, where we got the groundhog from.
As far as extruding it, well, you could
Well, yeah, pumping it through a hose, yeah.
hard to convey it from one location to another. But as far as, you all extruded product, right?
No,
I'm saying that he's got equipment where it's just a pump. It's not like a groundhog or.
He came from Easy Grout, which is the manufacturer of that orange unit sitting on the plant floor, which we've used on the masonry side over the years with some other products of theirs. But he came out because he was concerned it might not go perfectly, which it didn't on Thursday, which you guys unfortunately didn't get to see.
We've pumped UHPC with both steel fiber and PVA fiber. It works. You have to have a very cold UHPC when you do it. Pump adds energy into it.
Are you using a hydrostatic pump or?
Rotor stator.
Well, you said more like a slip pump type?
When I hear extrusion, I'm thinking about how they
More like
make the
what
material.
you guys did
So, I don't know that I would correlate the bridge overlay to extrusion. I'll say likely it can be done, but I would circle back so that I could answer more intelligently. Anyone else?
Have you tried any shrink reducers in the UHPC to cut down on linear shrinkage? Like a CKNS or something?
We haven't. So we have used some shrinkage reducers. Part of our material, one of the things we do is engage nanotechnology. We use carbon nanofibers and other nanoparticulates, which really help us with our shrinkage. So we don't generally have much of a need for it. But you know, I'm familiar. I know a lot of UHPCs that can and do. They behave a little bit differently. A lot of them, you know, they're shrinkage reducing in the sense that they just try to generate an expansive reaction up front. It's something, if you were going to try it in your production line, you would certainly try it on a small scale and validate what impact it has on your fresh and hardened properties.
Yeah, they can be dangerous if you get a little too much.
Yeah, exactly.
I've had a bit of luck with it.
Okay.
And aggregate size too, particle size. You can work with something a little bit bigger on the top size, as well as grading down on the small size. That seems to help shrink it a lot.
Sure. Yeah, I mean, shrinkage can certainly be addressed through appropriate gradation of mixes. You know, so when you buy a prepackaged material, like if you were to buy our material, we intentionally grade our materials to get that optimal performance. And Roy, I think, you know, he spoke to particle packing and also the learn by, you know, trial by fire, trying it, learning, trying it again.
And Greg, could I ask, when you talk about temperature, what temperatures are you talking about? Lower is better?
Yeah, I mean, we're typically casting at 45 to 52 degrees.
Tough one. Okay, thanks.
What do you think your peak temperature would be? Greg?
During curing,
Yeah, at the highest point of hydration.
it depends on the product. The thin slabs at like 5/8 of an inch typically hit about 110, 120.
Are you using ice?
Yeah, 100% ice. Yeah, that's why our mix times are so long compared to others. So if you use, like on bridge work or something, you use 100% water and you can get mix kicked out pretty quick. That mix hydrated very rapidly. But we're churning ice for a very long time trying to get it to melt. So
Right.
there's a huge difference between water at 32.1 degrees and ice at 32 degrees. The thermal reactivity that takes place when ice changes to water, that it absorbs a massive amount of heat during that state change. So that's why we have to use
We're
ice.
probably 60, 40.
Actually, if you
water
can,
ice.
No,
get
I
crushed
put-
ice or shaved
I
ice.
put less ice in there than that. I
and
put as
then
much as I had to do to keep it
100%
down,
ice.
to keep it
in
after
your
nice
mix.
in the,
That's
in
gonna
the
melt
bucket because.
almost right away.
We don't get the temperatures as cold that way.
Really?
Yeah. Yeah, it does turn quicker, but it doesn't get as cold. So the larger ice chunks actually work better. They absorb more heat over time. So that's a trade-off. You get the flowability to work with the material with a very cold mix, but it does take longer to produce a batch.
You said you're using 100% ice, so you're not using water, you're using just ice.
Yeah.
Way enough ice.
Yeah, I mean, in some mixes, if it's we're filling very thick form, and you get that hydrostatic pressure on the material to get it to flow to its own weight, we can use a little bit of ice and water, but typically our flat panel production is 100% ice all the time.
What about plasticizers? Do you ever had any extra plasticizer?
Extra? No, I mean, the formula is the formula is the formula. Get your hands slapped pretty hard if the batch plant operator puts a
Yeah.
extra drop of water in it or
Yeah.
chemicals that weren't prescribed. So,
You guys use
I-
what color?
iron oxide pigments.
You use pigments?
Yeah.
Dry? separate mixer. And then,
Yeah, every single batch of product we make has some type of pigment in it, whether it's white all the way through the lines.
Anyone else, thoughts, questions, concerns?
What, talk about, maybe I missed it on the tour, is there, what's the ability to patch, to fix anything to repair?
Yeah, I don't think we've had any large spalls that we've tried to patch, right? It's been mostly in regards to challenges we've had with maybe bug holes that are stuck on a vertical face or something due to a form liner. I kind of spoke to it before, but we had trouble just trying to take our regular mix design and reduce it down to what would be like a patch mix or a sacking mix, as people call them. And we ended up having, because of the huge cement content, having to like use some of our super plasticizer and stuff in the sacking to get it where it was spreadable and we could get it in where we wanted it and stuff like that. But part of the great thing about the stuff is, you know, it's super durable, so hopefully you won't have chunks of it breaking off and things like that.
Would it look, because it's fairly consistent fiber across, are you putting fiber in your patching to make it that consistent color?
we haven't had a big enough,
Yeah, we haven't had a big enough section to try to fix.
so all we've had is bug holes. And you have the same problem you would have with almost any precast, which is that experimental to get the color right.
What about you, dude? Second patch?
Oh, we use an acrylic binder, so a number of times we've just taken scrap production, grind it to powder, and mix it with acrylic and patch it that way. Sometimes you have to adjust the color to get it right, but it's usually close enough for a chip or something like that.
So you take the scrap from the piece itself, grinding it down into the powder, adding acrylic, and using that as a base fluid.
Yeah, build that up and then sand it smooth. The color's not always right, but you can adjust the color a little bit up or down based on the first trials and experiments. But apply a little acrylic to the broken off area, the raw material first, to allow the wet acrylic material to absorb into it better than hot. So it's a pretty good luck with that.
Any other questions? How about any future topics or issues at the plant? Anybody interested in learning about anything in particular that the APA can help out with? You'll all receive an email after the workshop. You'll get an email, and there'll be an online questionnaire about your experience here. If you could fill that out for us, we'd really appreciate it. It's good for us to know what was good and what wasn't, and what we can be better at. We want these workshops to be useful for you guys. We want that education to get out there. We can't thank John and Beth enough for everything they did for this weekend, so thanks to those guys. We have a few non-member plants come in. We really appreciate you guys coming here. Craig, thank you, and just all the plants that show up. It's awesome. The associates that support us show after show is just impeccable. We really appreciate you guys. Thank you for all your knowledge. It was pretty cool to learn about. A producer who's never done any UHPC, it's eye-opening, and it's obviously good to know about this stuff so we can talk to architects and help spread the word for other APA plants that are doing it. And a huge thank you again, Northwest and their guys and everything that they did. Just a quick reminder on tonight, 5:30 at the dock. It's a short walk. There is parking over there. We're not sure if you're gonna have to pay for parking or not, but there's two lots that are adjacent to that pier where we're headed. It's a mile walk. If you want to walk, you can Uber, but you do have to get yourself over there. It's 5:30 boarding. Anything else, John, you wanted me?
What's the document? It's on the,
Thank you.